Question 2. Chlorine reacts with many elements and compounds to form chlorides. Table 2 shows information about some chlorides of period 3 elements. Let's move on to the first one. Formula of chlorides. So there are 3 period 3 elements here. So when the sodium reacts with chlorine, it forms sodium chloride. Magnesium with chlorine form magnesium chloride. Silicon with the chlorine forms silicon tetrachloride. So these 3, they are easy. Now let's move on to the structure. For the sodium chloride and the magnesium chloride, they are both ionic compound. Ionic compound, most likely they are giant ionic structure. So therefore, okay, if the sodium chloride is giant, magnesium chloride also giant. Is something like this. The cations and the anions they will be nearby and arranged alternately. So it's a giant structure, means it will form a ionic network. You see, means the negative and positive particles, they always arrange alternately. So for this SiCl4, right, so you have to understand the structure is a simple structure. It's not a giant molecular. Why? Because this molecule SiCl4, they are just 1 silicon and 4 chlorine in one molecule. It will not really form a network like these ionic compounds. So therefore, between these molecules, they just have a weak intermolecular forces. So that's why this is a simple structure, because the molecules, they are separated. Okay, a small molecules only. So it's a simple structure. For the third one, bonding of chloride. So this one is easy. For sodium chloride is ionic bonding. Magnesium is ionic bonding. The SiCl4 is covalent. Covalent between the atoms in the molecule is covalent. Between the molecules then is just van der Waals forces, the intermolecular force. Okay, next part. pH of solutions formed on additions of chloride to water. Sodium chloride, when it dissolves in water, so it will form neutral solution, so pH 7. Magnesium chloride is slightly acidic than the sodium chloride. It will be around 6 to 6.5. So in this table already given 6.2. For the silicon tetrachloride, when it dissolved in water, so it will form the solution with pH 2. pH 2. Why? Because this SiCl4, once it reacts with water, it will form 2 things. It will form a white precipitate, which is the SiO2, and it will form this HCl. So because it's formed this HCl is a strong acid, so that's why the solutions it will goes to pH 1 to 2. So you just put pH 2 is enough. Part B. When the chlorine reacts with coal, sodium hydroxide solution, chlorine is both oxidized and reduced. The products are sodium chloride, water, and G. Part 1. State the type of redox reaction in which the same species is both oxidized and reduced. So it's quite clear that the chlorine now is undergo disproportionation reaction. Why? Because the chlorine's its oxidation number is increased and decreased. So it's from 0, for example, is here, from 0 to -1, and this one is +1. So means the chlorine is the elements that's being reduced and oxidized. And the type of redox reaction, we call this one as disproportionation. So part 2, identify what is the G, means the reactions between the chlorine and the cold sodium hydroxide. So again, use this equation. Chlorine with the sodium hydroxide, if it's cold condition, so it will form sodium chloride, and sodium chlorate 1 means the NaClO here and the H2O. So means the G here, it must be the sodium chlorate 1. You just give the formula NaClO. Part 3, write an equations for the reactions between the chlorine with hot sodium hydroxide solution. So if it's hot condition, then the chlorine will oxidize further. So it will oxidize from positive 1 now increase to positive 5. So when it's cold, then it's positive 1 oxidation number. When it's hot, then it's positive 5. So the equation is quite similar. It's just this sodium chlorate is different. If it's cold, then it forms sodium chlorate 1. If it's hot, then it will form sodium chlorate 5. So you just balance accordingly. Right? It will still form the same salt, sodium chloride salt, and the water. Right? Part 4. Describe fully what is observed when the silver nitrate is added to aqueous solutions of the chloride of sodium. This one is the first observation, then followed by dilute ammonia. This is second observation. So first, this is what happened. Sodium chloride solution, when you add silver nitrate, so the silver ions will form precipitate with the chloride, means it will form this silver chloride precipitate. So what you will see is the white precipitates here. So white precipitate form, which is the silver chloride. And second, if after that the ammonia solutions add to this mixture, the silver chloride will dissolve and it will form this solution. So the silver will form this compound which is soluble in water, the Ag NH3 bracket 2. So this compound is soluble in water. That's why it will form a clear solutions later. So the second observation is this: the white precipitates dissolve in the ammonia solution. Part C. An excess of chlorine reacts with phosphorus to form PCl5. Okay, part 1. PCl5 is a simple molecule in gas phase. It also exists in a solid form as two ions, PCl4 positive, PCl6 negative. Now, complete table 2.2, identify the shapes of each of these species. So this PCl4 positive already given is tetrahedral. So it's look like this one. The phosphorus with 4 chlorine here, right? 4 covalent bond. So it will form this tetrahedral geometry. Because the phosphorus now has a 4 bonding pair, so it will form tetrahedral. How about PCl5? PCl5 is something like this. So phosphorus form 5 covalent bond with chlorine. Because now it has a 5 bonding pair, so it will form this geometry or this shape. So which is a trigonal bipyramidal. Of course, you need to mention the base. This is a trigonal base. And after that, it will form the 2 pyramid, means the trigonal bipyramidal, isn't it? So this is the first one. Below, there is another one, right? So here. So therefore, you must give the full name. Trigonal means this trigonal base, and it must be bipyramidal, 2 pyramids there, right? So after that, PCl6 negative is something like this, because now the phosphorus with the chlorine is formed 6 covalent bond, means a 6 bonding pair surrounding the phosphorus. So it will be octahedral geometry. Part 2. PCl5 reacts with J to form H3PO4. Identify what is J and state the type of reaction. This one you have to recall what you learned in this inorganic chemistry or the periodicity. The PCl5 with water, it will form these 2 acids. So it will form H3PO4 and HCl. Means the J now, it must be water, must be H2O. So J is H2O. What is the type of reaction? The type of reaction is, of course, is better for you to put hydrolysis. Why? Because this compound now is reacts with the H2O and is form other things. So the type of reaction is confirmed hydrolysis. So this is the best answer. Any things that react with water and form other compound, so the type of reactions you always can say that is a hydrolysis. So it means using water during the reaction. Part D. Okay, chlorine reacts readily with propene to form K, which is a 1,2-dichloropropane. So means this one, 1,2-dichloropropane. The K can use to form L. So this is the compound after the reaction 2. Now let's move on to part 1. Complete figure 2.2 shows the mechanisms for the reactions of the chlorine with the propene. So this one is quite easy. Is always asked. The first thing that you need to do is please put the partial charge on both chlorine. Means the partial positive and negative. It's better for you to put the partial positive near to this propene. So next step, you need to draw one arrow from the double bond point to the chlorine with partial positive. Because this one is electron rich, so it will donate electrons to the partial positive side of the chlorine. So next, you need to draw another arrow from the Cl-Cl bond here, this bond, and make sure this arrow you need to point to the chlorine with partial negative charge. So this one, it shows that the 2 electrons here is moved to the chlorine, and eventually this one will form chlorides later. Means this one will form this chloride. So after this step, we know that this carbon will form a new bonding with the chlorine. So for example, this one. So the carbon and the chlorine form a new bonding, and this carbon is electron deficient. So you put a positive charge here, because initially there is a pair of electrons that share by these 2 carbon, but this pair of electrons used to form a new bonding, right? So it's here. So this carbon now is electron deficient, so it's a positive charge, and you need to of course put this chloride, so the chlorides that form here, and make sure you put negative charge and the lone pair. And you need to draw one arrow from this lone pair, point to this positive charge, or point to this carbon with positive charge, to show that it's form another bonding. means another CCl bond, so which will form this compound. So this is the whole mechanism. If you want to know the details about all the marks, you can of course refer to the mark scheme. It's available in many web page, right? So you can get all the details in the marks. Okay, part 2. Identify the reagents and conditions for reaction 2. Reaction 2 is this one. Reaction 2 is elimination reaction. So means this chlorine remove with this hydrogen. It's not together actually. So means this hydrogen and this chlorine being removed and form this L. So how to get this alkene or this compound L? First, you need to use the sodium hydroxide in ethanol. When the sodium hydroxide in ethanol, then this sodium hydroxide will use for the elimination reaction. If it's in water, then it's not elimination, it's a substitution. So that's why you must put ethanol here. This is the conditions or reagents and conditions that needed. So the condition is of course it needs heat. So means sodium hydroxide in ethanol plus heat. So this is a reagents and conditions that needed. So I show you how the reactions works. So this is the compound K, this one. So when we use a hydroxide in the ethanol, so this hydroxide will attack the hydrogens on adjacent carbon. Let's say this is the chlorines that going to removed. So on this adjacent carbon, so these hydrogens that bond to this adjacent carbon will get removed. Means the hydroxide will react with this hydrogen and form H2O. So means these two will form H2O. And after that, the CH bond here will break, and these electrons will move to the CC bond to form this double bond. Once the double bonds form, the CCl bond need to break. So just one arrow from this CC bond point to this chlorine, and this chlorine now it will form chloride. Okay, this one will form chloride. So means after the reaction you get three compounds or three species. So one is the compound L, another one is H2O, another one is chloride. So this is the reactions about. So part 2 is this sodium hydroxide in ethanol and heat. So the last part 3, draw one repeat unit of the addition polymer that's formed from L. So this is L. When you want to draw repeat units, it's better you draw the structure something like this. Means you use the monomer and you draw it in this way. So this is how it looks like. I mean the compound L. When this one want to form polymer, the pi bond needs to break here. Need to break, and this carbon and this carbon will form bonding. So means double bonds break, or we can say open up, and it's form this two bonding. So eventually you'll form this polymer, and you just need to draw one repeat unit, something like this. So means your answer just need to be this one. So this one is just to show you how to do it. Your answer is just this one, right? Make sure you show these tails, right, with the structure. Okay, that's all. Thank you.